Hey y'all, today we're going to be talking about vectors and scalars. To really briefly describe them, a vector is simply a physical quantity that has both magnitude and direction, while a scalar quantity is one that has a quantity that has just magnitude. So I need to obviously define some words just to not be confusing. We'll do physical quantity there, is there? At least in physics. So when we think about the word magnitude, let's define that as well. All that really means is just amount. So how much? And direction, obviously, is just which way you're going, right? Which way you're pointed, whatever. So if I were to give some example of scalar quantities, because these are kind of the easier ones, these are anything that don't have a direction included. So for example, area, right? When we measure the area of like a square, we don't have a direction that we measure in. Really, it's just the area, right? Then we can also say volume, time, temperature, right? These are all different types of scalar quantities. They don't have direction. They're just kind of like a how much. Another one might be your mass, right? Different from weight. We'll talk about weight later. When we talk about vector quantities, these are things that do actually have direction attached to them. So some that you may know or you may not know. One is, for example, force, velocity, similar to speed but a little bit different, acceleration, momentum. So here are some. So all of these four that I've written down, they all require direction included in their description. If you guys remember back to the last lesson, we started having these arrows, right? So we had the bus moving in a positive direction. We had the person moving in a negative direction. These are actually velocities, right? They have not only a magnitude, the 20 miles per hour for the bus, but also a direction. And so vectors and scalars are simply things that we use in physics to describe kind of like the world around us. Another thing that we need to mention about vectors is that vectors are represented by arrows. When we talk about the magnitude of a vector in terms of a graphical representation, which is just to say a visual one, is represented by the length of an arrow. And the direction, obviously, is represented by which way the arrow points. If we go back to our bus example, you actually kind of see I kind of drew it really poorly. This vector and this one is twice as big as the other one, but one is nearly the exact same size, so I drew them really badly. If I were to draw them again, so I have this bus, right? A better representation might be something like this, right? Where the guy is maybe moving something like that, half the speed of the bus. This is our 20 miles per hour. This is our 10 miles per hour. So these vector quantities manifest themselves in two ways, right? So we talk about the graphical one. They also manifest themselves as mathematical representations, specifically in one dimension. And all I mean by one dimension, I'll define this as well, simply means that we can only go or move or interact in a forward or backwards motion. So for this bus example, technically speaking, this guy could jump into the air, but I'm not really concerned with that. If we're looking at one-dimensional motion, we're only concerned really with forward and backwards, either just up or down, in or out, just one specific one. So mathematically, we've already talked about this too in the last lesson, we need to choose specific directions so that we can actually calculate these analytically. So for this one, for example, if I wanted to figure out what is the speed of the person running, let's change it up. Let's say that this is our positive direction, this is our negative direction. Well, graphically, we'd actually add them using something called the tip-to-tail method. Tip-to-tail method. On this method, you add vectors graphically or visually by aligning them tip-to-tail. So, for example, we have a reference point, and we know our 20 meters per second, or sorry, miles per hour, is about this long, going that way. And then I'm going to use a different color. Our 10 miles per hour comes back something like this, right? If I were to add different types of vectors together, they would kind of manifest themselves looking like this. So we have this is the tip, this is our tail. If we wanted to add another vector, let's say this one goes directly upwards, right? We see that. If you want to add another one, right? So they always have to go tip to tail, tip to tail. You can, like if you had a vector and you added it like this, that's not good. That's not going to work out. So make sure. Let me just redo this. This one looks ugly. Make sure you're always adding them tip to tail. So going back to our example, the way that we would calculate the magnitude of the overall vector is we take it from our starting point to our final point, which is right here, and our vector then that represents his overall speed in our frame of reference would be the length of this vector right here, this red one that we have. And mathematically, we know that it's actually pretty easy. We have a negative 20 miles per hour plus a positive 10, right? Remember, we changed our directions. And that gets us then a net velocity of negative 10 miles per hour. So although this person might be moving backwards, relative to someone outside of the bus, staying outside looking in, right, he's looking in, he's going to still appear to be moving in our defined negative direction. So just to reiterate, directions, you can choose them always. Your frame of reference, you can choose them always, but you always want to choose one that makes life just easier. So we have this tip-to-tail method. We have adding vectors graphically, and we'll talk way more about this later. This is just a really, really, really quick introduction to kind of give you some idea about what these are. In the next topic, we'll be talking about distance and displacement, and so that'll kind of give you a better idea of what these are and how these really interact. So thanks for your time. If you have any questions, please feel free to contact me.